Okay, so the topic today from me is going to be people flow solutions to enhance your building performance. And it's actually going to focus on efficiency. And the reason for that is if you go back to the summit of Copenhagen, one of the things the summit actually stated and made very clear was that if we look at renewables, nuclear or whatever, other energy sources, we will not reach the trajectory needed to keep the temperature rise down to 2%. We actually need more than 50% increase in efficiency to be able to even reach it. So that's the reason why I'm talking about efficiency, and nothing else but efficiency. So let's start. Next slide, please. Yeah, so I'm going to talk about efficiency in design, efficiency in construction, and improvement of efficiency in operations, so eco-efficiency. So let's continue. Let's go to efficiency in design. And that's very important because what you plan is what you're going to get and what you're going to have to live with. Yeah, so if you plan it wrong, you will have to live with it for the next 20, 30, 40 years. So that's it. So let's look a little bit on what we have done in the past. If you look at this here, you'll see an elevator down with a conventional system having a lot of stops going up. In an up peak, you will really make a lot of stops. And if you are running at about 6 meters per second, each one of those stops will cost you about 10 to 12 seconds. So it's not going to be back very fast, that elevator. It's going to take quite a long time to do it. So the first thing we do is, of course, zone. We cut the zone into sections so that we have less floors to serve, and therefore the number of stops is going to be reduced. And if you look at this diagram, which I have here, this column here is the number of floors above grade. Yeah, so how many floors are served above grade. Doesn't matter whether it's a high-rise, but it's the number of stops which we make above grade. The H which you see here, that is the probable reversal floor where you will reverse. S is actually the number of stops you will make on the way up. And you still have to make the one stop down to pick up people in an up peak. Now, if you have a 21-person car with about 16.8 passengers inside that car, you will make quite a few stops. And what you see here is you go practically to the top, but you make 10.6 stops. 10.6 times 12, that's about 120 seconds easily lost, making those stops. It's a lot of time, 2 minutes losing in stops. If you cut that down in a zone, you had 16 floors first, so 2 zones of 8 floors now. You'll see that it goes down to 7.2 stops. You will still go to the top of each of the zones, but you will make only 7.2 stops. That's 3 stops down. This is about 40 seconds faster around. And that means I can transport more people because the elevator is there a lot sooner. Yeah? So in that way, we can get more capacity out of it. Typically about 20, 30% you can easily get by zone. And that is why we zone high-rise buildings, to make it more efficient. So that's the first part. If you want to go further, your building gets bigger, you want to reduce that core further, you start stacking cars on top of each other. We start going to the double-deck elevator. Yeah? So what you now have is you have twice the load in the same space, core space, and you even have simultaneous loading and unloading, which also helps. Your building gets even bigger. So now you're going to actually split the building. So that is stacking up buildings on top of each other with a sky lobby in the middle. There's quite a few of those around here in Shanghai already. This, I think, is one of the highest concentrations of sky lobby buildings in the world here. And you're going to have to need one elevator, which is a shuttle elevator, to take you up. But what you can see is instead of having 4 cores side by side, taking and increasing your core, you now actually only have about 3. So you save a full set of elevator core, which gives you more efficiency out of your building. Okay, so that's the next thing which we will do. So we start zoning, stacking buildings. And as I said, this place is very famous for that. Those are typical ways. And then we had new mechanical ways to actually increase the building efficiency. One was the machine roomless elevator. You don't have that hump on top of the building, so you have, in principle, if you have restricted height, a complete extra floor of space. Yeah, so that adds quite a lot of extra space, making the efficiency bigger. That's a lot of square meters extra, that one extra floor. And it's definitely worth doing that. In Europe, we have something like a telephone booth elevator. You know, the thing is like a telephone booth, you know, very small. And very often in Europe, they don't even have automatic doors. They don't even have car doors sometimes. Yeah, they're really, really small. Accessibility in a wheelchair, just forget it. Just try opening that door. It simply doesn't work. Yeah, it doesn't work. So what do? What did we do? We actually tried to figure out how can we get that space so tightly built that we can get a bigger car and actually add an automatic door and still get a guy in. And that's why we came up a while ago with the MaxiSpace elevator without the counterweight. Of course, it uses a little bit more energy, but it definitely makes the building accessible now. And this is a product that really takes off at the moment because there are so many of those buildings that are completely inaccessible. Then we have systems in the future. Yeah, that little question mark. I can't answer that, of course, because then I'm in breach with the stock exchange. But there's a lot happening on that as well. And I can tell you there's a lot going to happen in building efficiency increase in the next couple of years. There's just so much happening there. And it's not just us. I know one of our competitors just came out with 2 cars in the same hoistway moving separately. Yeah? Still don't think it is as efficient as putting destination control on a double deck. I believe it has more capacity than that, clearly more capacity. But that's one other solution that can solve certain problems in the industry. And you will see a lot more of these solutions coming out. I'm pretty sure every one of the companies is working on new solutions for the future. Then we go to the intelligent way. Yeah, the intelligent way of adding efficiency. And that is whole call dispatching, adding more intelligence, you know, getting more information before you enter the elevator, so getting information already outside the elevator on where you want to go to, instead of first when the elevator arrives inside the elevator car. So these kind of whole call systems have dramatically improved the efficiency of elevating and therefore reduce the core and gives us more chance to improve, to get that 50% extra which we really need in efficiency to be able to keep the carbon factor down. So we're now actually in a system where every car has its own zone. If you have a conventional destination system where you have all the DOPs on all floors, the destination operating panels where you enter your destination, then you can't enter in the other car arriving. You have to enter into the assigned car. So it's one zone. That car is your zone, and you can't use the other zones. You can't get to the floors. So, but the thing it does, now putting people with the same destination in the same car, actually all those people are put in that car. I put these actually in 2 cars because we don't come at the same time. Sometimes we need to use more cars. But what you can clearly see is the number of stops is dramatically reduced. Yeah, and that's what it's about. We want to get those numbers of stops down to get more capacity. So I had, earlier in the old system, 16 floors. I had 6 elevators there, which you could see. The minimum number of stops is approximately the number of stops divided by the number of elevators. So my elevator could be reduced to about maximum 2.5 stops. Now my table only goes to 5, but at 5 I see I make 4.9 stops, so nearly 5. So at 2.5 it's going to be close to 2.5. From 10.6 to 2.5, that's 8 stops reduction. At 6 meters per second, that's 100 seconds faster around. You know, typically you can say that in an up peak, a 6-car group will get you 60 to 80% more capacity. An 8-car group, you can get double or even more than double the capacity. Yeah, so this is what you get out of this thing. So it's really a lot more efficient. If you start putting destination control on double decks, you actually get in the up peak about 3 times the capacity from a conventional elevator in the up peak. Yeah, so it's quite a lot more. But up-peak is not the only factor. I still want to warn, always ask for your lunch traffic simulation because that's extremely important. How does the system work? Very simple. You give your destination outside the elevator. It tells you which elevator to use. You move to the elevator, look at it, get in, and enjoy the ride. That's it. Yeah, here you go. And step out on the floor where you need to step out. Now, one thing it does, of course, is, now just imagine being that person here, and that car arrives in this lobby. I would say no chance whatsoever. Yeah, you'll see people really trying to move around in that lobby. Really not a nice feeling. If you're now standing in front of the right elevator, you just enter, and you know, the stress is gone. It works nicely, perfectly right, and it takes other problems away as well. Yeah, there are many problems it will remove. Now that's the first. I call that conventional destination. Here in Asia, we're actually selling more of the hybrid destination. In Europe, it's more conventional. Here, it is more hybrid destination. And that's a cultural thing. We have been checking that. That's a cultural thing. Hong Kong is very European. That's still quite close to Europe. Yeah, you see a lot of the what I call the conventional destination system. But in Asia, people like to stay and remain in control. And we have come up with a hybrid system. What the hybrid system actually does, it helps you also to reallocate the elevators in the lunch periods. That's actually quite unpredictable because traffic away from a heavily used floor is predictable. You know the major flow. You know exactly how to handle that. Yeah, and it's predictable. Traffic towards a heavily used floor, in between, before that heavily used floor, yeah, you have assignments already on, but assignments come in pretty randomly. You can try to estimate it with very good artificial intelligence, but then you need to add artificial intelligence and traffic forecasters. But it's pretty unpredictable. And if something comes in, it might not be the optimum anymore. Reallocation there will help you. Yeah, so with reallocation, we have there the reallocation possibility for these kind of situations. And that is why the hybrid is still okay. I know that most of the majors have it already and are using it. Some of them are not. Then there are new things coming up. Again, I can't tell you all, there's a lot more, but the thing we all have in our pocket, typically the telephone, yeah, is definitely one of the things coming up which we will use. Yeah, for example, if you go to IFC here, the International Finance Center at the Ritz-Carlton, we have it in our pocket. You just call the elevator with your telephone, yeah, and you don't need to touch anything, you just get in. It is pretty nice, and we have it on several projects in the UK already. So the telephone in use as your own personal destination device. And you can put it on a non-destination elevator and still get it to use as destination. You can combine anything in that way. In principle, making the hybrid a very open platform to do whatever you want, also for modernizations. And there's a lot more to come. Yeah, and I'm pretty sure the other guys will tell you exactly the same. If you need services to calculate your traffic, the first service which we have here, which is the quick traffic, just go to the Apple Store, you can download it, you can play with it. That's a very simple tool, which is pretty exact still for concept design. So you can run around, go to the Apple Store and just download. You put the word Kone and you can find it, and you download that app. Use it. It's free of charge, you can play with it, and whenever you have problems, just send us a question and we will answer it for you. The other one which we have here, that is TrafCalc. Just contact our guys, you get all the parameters, and if you really have a very difficult case and you need full simulations, we will do that for you as well. Then we have people flow efficiency in construction. Jump lifts. You know, we typically have bottlenecks, moving people, moving materials. Those are your bottlenecks. And if we use vertical transportation for that, we can help you. If it's cranes, unfortunately, we've sold our crane division, so we can't help you there anymore. But we can help you. And what we have done is we've come up with what we call a jump lift elevator, a self-climbing elevator, not needing the crane, which actually jumps as the building goes up. It provides you full transportation capability with the safety of a conventional elevator. It's CE certified, so it is actually authorized by an authorized body, check that all the safety methods are there, and it's CE approved. Yeah? All our jump lifts are CE approved. And you can use it. I will show you quickly how it works. Can you put on that video there?
What is Kone Jump Lift? Kone Jump Lift is a method which uses the building's permanent hoistway and standard high-speed elevator technology for construction time transportation. It's fast, safe, and convenient. This new yet already proven Kone Jump Lift technology provides a huge performance improvement compared to traditional site transportation methods and offers tangible benefits for the builder in medium, high, and high-rise buildings. For example, in this project, Marina Bay Sands, Singapore, the builder used 13 jump lifts to meet the challenging construction schedule. What makes the jump lift unique is the moving machine room that jumps upward when the building grows. Kone Jump Lift is self-climbing, so it does not need a crane to do the jump. The jump height is typically 2 to 3 floors at a time, so it can serve all the floors to the top minus 2. The jump can be completed overnight to reduce the service break. Kone Jump Lift is fast, with speeds up to 4 meters per second, a capacity of 4,000 kilograms, and a travel up to 400 meters. It thus outperforms all traditional means of site transportation.
We have the capability to move 4,000 kilos at 4 meters per second over more than 400 meters with this. Yeah, so we can really move a lot of traffic through the building. And if we know it in time, we can, for example, take care that facade elements, everything can go with the elevator, not a problem. Then we go to people flow efficiency in operations. By the way, typically the jump lifts will reduce your construction time by roughly 20%. Yes, so if you have a 2-year contract, with 24 months, you can get 4 to 5 months. You can finish off quicker with jump lifts if you have the right amount. It's typically that amount. Then people flow efficiency in operation, eco-efficiency. There's a lot of things we have. Yeah, so highly efficient motors, permanent magnet motors with incredibly high efficiency, much higher than what any squirrel cage motor can do. Regenerative solutions. We have regenerative solutions. We have regenerative solutions for all the elevator systems now. Even for the low loads, you can get it from us, not a problem. LED lighting, of course, standby solutions like switching on the light or switching off. You switch off the light, we will switch it on because we know we're going to stop on floor number 5. We can switch it on for you as we get there. Destination control typically doesn't reduce a lot of energy if you have the same number of elevators, but if you have a brand new building, you can reduce the number of elevators, and then you save carbon footprint quite dramatically. And on the escalators, lubrication step-free, well, it means no oil. Then you have regenerative solutions and the eco-efficiency, the start, stop, slow down, whatever. That will take a lot of the energy out of the system. And then the eco-mod, don't even need to remove your old truss out of the building anymore. You build your new escalator, a brand new escalator in your old truss. Not needing to break down walls, not cracking your floors, not taking walls down. It's very much faster in that way and saves you a lot of carbon footprint. Then you have the eco-efficient sliding doors. Why on earth, when it's hot in China, do you open up the door fully to get that beautiful cold air run out of the building? Yeah, we don't want that. So if there's no heavy traffic, why to open up the door fully? So we have all these systems in place to keep the doors more efficient and keep the building more efficient. Now, in 2006, we made one big promise. We will reduce our carbon footprint from what was already extremely efficient with the monospace by 2010 with 50%. And we kept that promise. That really happened. Actually, all our elevators went down by 50%. In 2010, we made another promise that by 2012, this year, we will reduce it by another 30%. We've just done that. Yeah? So we've just done that, and we've just launched the products. Yeah? So that is another 30% down from what we did already in 2010. That's extremely low energy consumption. If you go back to history, this same elevator, which is shown here, which gives you that value, has now gone down from, when it was DC gearless, Ward Leonard, it went down from 35,000 kilowatt hours per year to now 3,800. So 90% is gone. 90% less. So, hey, if you need to modernize buildings, think about this. It's incredible big amounts if you really do it. There is only one rating at the moment clearly available. ISO is trying to make one, but there's only one rating clearly specifying the grade of the elevator. It's just like your fridge at home, between A and G. We can do all the products, and all our products, standard products, are in range A. If you do something strange with special lighting, of course, we will be out again. Yes, so it depends on the options selected, but all our products will be in grade A, whether it is single deck, double deck, machine roomless, it will be in grade A. Now, one of the things which we have now achieved with this new arrangement is that our machine roomless elevator, which is the most difficult one to get into grade A, is now grade A even without regeneration. So if you put regeneration on top of it, you're deep into grade A. Yeah, so, but even without regeneration, you are in grade A. I think at the moment we're the only company that does that. Yeah, to be in grade A without regen. If you want to be efficient, these are the things you have to do. Pick the highest possible efficiency. For me, that's a permanent magnet motor. You can't get to the same efficiency with a squirrel cage motor. It's simply not possible. Yeah, you don't get there. Regeneration of braking energy, absolutely impossible. You can save up to 35% quite easily. Yeah, and if the efficiency goes up, it's going to grow even further. Minimizing standby energy, LED, sleep modes, whatever. Keep it really low. Also selection of the components to keep it as low as possible, the standby energy. Minimizing moving masses. We've done a lot of work on getting weight out. Yes, a lot of work. And so it's light cars and light other components. We will work on that, and we are still working on that to get it even further. And we believe that very soon we will come with another 30–40% on the high-rise side as well. Then optimum counterweight balancing. You know, we're not always using the elevators to full capacity. Depends, you know, you typically can't fill an elevator to the maximum capacity. Yeah, so balancing correctly will also save you some energy. Now I'm going to show, can I get the slide still one more time? Sorry, the movie one more time. I'm going to show a little bit what you actually do. So in the typical old way, when we regenerated, when the heaviest part of the elevator is going down, we have to brake it against gravity. So we actually get energy back. We are regenerating energy back. And what we did in the old days, and which everybody else did in the old days, we actually put it in the resistor bank, burn it off, and you actually had to provide more cooling to take it out of the building. Yeah? So not a great thing. With the new systems, you know, when it starts regenerating, we actually take it back a little bit further. If you would put a meter in between, yeah, bring it to this distributor board. If you would put a meter in between, you would actually see the meter turning back. You would see here that, oops, it goes actually to regen side, gives you some extra energy, and you would see the meter run back if the meter could run back. But we bring it back to the main distribution board, and from the main distribution board, it will then go to the rest of the load inside the building. So it goes to lighting inside the building, cooling inside the building, maybe even running other elevators, computers, whatever, all the other electrical appliances inside the building. Yeah, so that's how it's being reused. And we will make sure that power factor, voltage, frequency are all set right, so it's immediately reusable for you. So this is what you need to do. Yeah, so for eco-efficiency, we can get really big reductions. We have seen, as you can see, nearly 90% since 2000 and since the early ages. You know, 50 times 0.5 times 0.7. That's something like 65% less energy consumed. I think we've done our part. We're not going to stop here. We're going to go further, and you will see big reductions still in the future. Thank you.